Good afternoon and welcome to this conversation on CRAN and front haul. And today I'm talking to Femi Adeyemi, the LTE solution architect at Fujitsu. This is part of a report on CRAN and front haul that Senza Fili has prepared in collaboration with RCR Wireless. Femi, well, thanks first of all for being with us today.
Good to be here.
So let's get started, and I was wondering whether you can give us an introduction as to what is that you're doing at Fujitsu on the CRAN front.
So I've spent a greater part of my career on the wireline, wireless industry, building base station routers. And now I'm involved with Fujitsu on defining the next LTE architecture, both for small cells and fixed wireless as well.
Yeah, and there is a lot of work to do there, because oftentimes we think of CRAN as simply, well, not simply, but moving, the baseband in a remote location. But there is actually much more to the CRAN architecture than just having a remote baseband. Can you tell us how at Fujitsu you're trying to capture the whole change that goes with CRAN?
At Fujitsu, we're looking at CRAN as a total solution, both in the present and as we march into the future. For us, just like you just described, it's not just remote radio heads and centralized baseband. What we're finding out is that as you add more and more access technology, remote radio heads, small cells, the likelihood that you are going to introduce a lot of data into your core is very, very high. So for us, we are seeing this as a complete solution where we understand what is going on at the access, understand the transport, the CPRI or front-haul transport, understand the core as well as all the individual chains that you meet as you go from that access into the core. So access, transport, aggregation point, as well as the core. We're looking at this as a complete solution for us. That's very, very important. We don't want to look at it as disjointed technology on the access or the baseband centralization or virtualization. We see this as a total solution.
So let's get started with the access then. What do you do there?
So on the access, we're very, very active in small cell deployment. We build our own small cell, both in the Far Asia and deploying them in Far Asia as well as in the Americas, both North America, US, and Canada. Fujitsu has been known, very, very well renowned for building very reliable remote radio heads that has been deployed in many of the mobile networks today. So on the access side, when you start talking about remote radio heads, we are very, very prominent in that area, as well as small cells for enterprise as well as residential use. So on the access side, we're very, very active.
Mm-hmm. Yeah, so that's step number one. Number two is the transport part, and that becomes more interesting and challenging at the same time when you talk about doing having a CRAN architecture in conjunction with small cells,
right?
Because of the requirements. So what's going on there?
That is very correct. So there's a stringent requirement of sending your IQ samples from the remote radio head back to your baseband unit. So in the industry terminology, you will have heard about CPRI transport. For us, on that front haul transport, we want to give the operator the variability, or allow them to choose, depending on cost, depending on their deployment scenario, which technology they want to deploy. At Fujitsu, we're really looking at three different areas in that front haul transport. Number one is what we call active CPRI transport, for example, where you're able to monitor what is happening with your remote radio heads while you are still in a centralized location. That is a little bit more expensive, but it gives you visibility into what is happening between your remote radio head and the central location on your fiber. For operators that are interested in cutting cost or not really concerned about what is really happening at the remote radio heads, we have a passive solution as well, a C or DWDM based passive solution. Now, there are instances also where, for example, when you have small cells that are outdoors and you want to transport your data back to a centralized location, and you don't have access to fiber, we also have a wireless transport solution that is E-band based. So if you look at what I'm trying to say, we covered all the areas that would be very interesting to any operator. So if you are interested in cost saving, we have that solution for you. If you're interested in monitoring what is really happening on your fiber link, it's available from Fujitsu. As well as if you do not have access to fiber and you still need to transport your data back into the core, we also have an E-band wireless solution as well.
Yeah, so basically, an operator can decide how to also mix and match. It's not necessarily that one operator only selects one solution for the whole network. Depending on where they are, they can pick whatever works better for them.
That is correct. So if you go back into what we've been discussing, we look at this as a complete solution. We don't want to limit the operator. We want to give you the what is available based on cost, based on fiber, as well as based on network topology that the operator may have today. That is correct.
Yeah. So let's go to the next stage, is the core and aggregation. What are you doing in that part?
So as we look at the deployment that is going on today, going from the distributed RAN into what we want to call centralized RAN, as well as the next stage of being a virtualized RAN. The first step for us is that we don't want to come into the industry with technologies that will not be deployable. So we want to follow what the operators are really interested in. Today we are moving from the distributed RAN into the centralized RAN. At the centralized RAN port, we have baseband aggregation happening. In the terminology in the industry today, we call that like building baseband hotels. So we have solution in that space, whether it's for small cell or for macro cell, and this will vary in the number of baseband units we're able to aggregate together, whether you want to aggregate large number of basebands or small number of basebands. And then the next logical step for us is to virtualize that baseband, being able to operate this in the cloud along with some specialized devices, so that we move in these three steps that I'm describing, starting from the distributed RAN into a centralized RAN, and then into the terminology that I will call a cloud RAN, which will essentially virtualize the baseband hotels that you have. With the baseband hotel, it's now easy to deploy logically, adaptively, sharing resources between the different basebands units that you have in the hotel.
Yeah, so it's more than just a one-step, simple one-step process here. How do you see operators moving across this transition, especially those that already have a network that sort of have to deal with legacy?
Yes.
On top of, so they have to look backwards and forward. We need to move forward, but they also need to take into account what they already have.
That's a very good question, in the sense that we are running into scenarios, particularly with established operators, where they already have a topology for their RAN architecture today. Now, you can go in and ask them, oh, you want to deploy C-RAN architecture? Let's pull apart what you already have and just start building from scratch. But that will lead to a disruption in their service. And so what we're finding is there are two layers that we're looking at, where we start with their existing architecture today, and when they have expansion to the current topology, we build that out as Cloud RAN or C-RAN. And so we keep what they already have in their network RAN architecture, but extend out C-RAN to their new deployment or attachments to their existing architecture. That's one scenario. Other scenario is when they have fresh greenfield deployment. Now we begin to think about complete CRAN architecture for such greenfield deployment. So we want to make sure we work with the operator and get the best out of existing technology while we introduce this CRAN architecture. And there are issues that we come across as we do this. They have existing transport layer. We want to make sure that the new CRAN architecture works with this with the transport that they already have in place. So it's a two-stage level. We're not going in to break apart what they already have. We're building CRAN on top of existing architecture, and then in the future also think about pulling out what they have today so that we can completely make it into CRAN architecture. So
how long will all this take?
It's already going. It's ongoing. Even as we are having this discussion, we are working through all these issues of transport. I can give you an example. We talk about frontal CPRI transport, which we are now going to integrate with, in most cases, fiber transport as well as Ethernet transport. We're working through those issues, and within the next 12 to 18 months, we're getting very, very close to fully deploying CRAN architecture with most, if not most, operators in North America.
What about the rest of the world?
Well, CRAN is actually very, very prominent today in the Asia Pac, in South Korea, in Japan, because of the density of the dense population that we have in Tokyo, for example. CRAN is really, really actually being deployed. So CRAN is not new to the rest of the world. It's new to North America. But we're also finding that in our metropolitan areas, we can replicate what we're currently doing with CRAN in the Far Asia, in US, for example. So it's almost as if we're coming from the Far Asia back into North America as we go forward.
Yeah. No, that's you're absolutely right. In Asia Pacific, there has been so much work already. Now, in terms of the virtualization, the end game, the end target is to have all the hardware to be virtualized. Generic hardware that can support any processing. Do you think it's possible for all the RAN functionality? There is a lot of debate on this as to whether we can go all the way there, or at some point it doesn't make any sense anymore. That you still need specialized hardware for some of the functionality that are RAN functionality, because timing is so crucial. What is your view on that?
You're absolutely right. Using generic servers to virtualize baseband functionality will not be completely possible because of the kinds of data that needs to be transported between the baseband and the remote radio heads. So my view is that we can virtualize as much of the baseband, but we'll still need specialized hardware when it comes to switching, for example, so that we can do high-speed switching of the IQ samples that are going from the baseband into the remote radio heads. Mm-hmm. It is not completely possible to virtualize the baseband without some form of specialized hardware. We will still need a little bit of specialized hardware to accomplish this.
Yeah. Now, we talked a little bit about small cells before. Mm-hmm. And there is some people think that small cells and CRAN don't mix very well. Others think that CRAN is actually what small cells need to succeed. Where do you stand on that?
What is very, very important about small cell is that we are able to do away with all the large-scale network planning that needs to happen, which is what we have today in our current RAN deployment. Today, in your RAN deployment, we do what we call network planning. You have to know where these this RAN today, where they're located, what they're doing, before you can introduce new ones. If you don't do that planning properly, there will be all kinds of interference. Now, with small cell and the way it has been defined, the SON capability that small cell has is really going to help a lot, because with SON, we can actually literally place small cells anywhere we want it to, and that can be managed from a centralized port. So my view is that CRAN really needs small cell to be more effective, because we can introduce remote radio heads, we can introduce small cells such that they can work together interchangeably without having to worry about network planning as well as interference. So you're right. We need small cell is needed for CRAN effective deployment as we go forward.
Yeah. No, that makes perfect sense. And now let's go back to the operators in the sort of medium to short to medium term. What do you see that they are mostly focused on?
The operators today, they're mostly focused on integration. We know that CRAN works. We know it has been deployed effectively in the Far East. But the topology that we have in North America that makes us very unique is that we have the metropolitan areas as well as the rural areas. And so it's that integration of bringing in CRAN into this topology that is only peculiar to North America. So the challenges are how do we migrate from what we have today into becoming CRAN? Do we do it this gradual, or go and break what we have today and just start from a playing field, which is not possible, by the way. And then the third and final challenge that I see is, how much do we currently have in our transport to support what we're bringing in? So a lot of studies have been done today in terms of, do we do this for just new greenfield deployment? Do we marry with our existing RAN architecture or RAN deployment? Or is our core ready to support the kind of data that we're going to bring in? Those are the things that the operators today are going through, fleshing all of that out as we get ready for the full-blown deployment within the next 18 months.
Yeah. And then, as you say, transport is going to be a crucial part, because that's what enables CRAN. If you don't have the front haul,
that's correct,
that performs at the right level, then everything else becomes a moot point.
That is correct.
So in that respect, there has been some debate in terms of using the SIP-based interface, or is it really necessary or not? Whether you use wireless or wireline. What are your thoughts on that?
It depends on what is available to the operator. In many of our metropolitan areas, even when fiber is available, it's very difficult to deploy, whether it's the function of breaking new grounds to allow this fiber to be placed, or in other areas, fiber is just not even available. So SIP transport, it's going to be very, very prominent to CRAN. And that's why at Fujitsu, we don't want to limit the operator in terms of what can be used. In cases where fiber is not available, we have the option of using wireless transport that will still be SIP based. And in places where fiber is available, the choice is whether you want to use active or passive. So for us, SIP transport is crucial, and it's going to be an integral part of CRAN deployment.
Mm-hmm. Yeah. Now, in closing, may I ask you, what are you going to be busy working on in the next 2-3 years of Fujitsu? What should we expect to see from you?
Well, the future of CRAN, and as we go forward, it's to allow resources to be shared among baseband units, shared effectively, shared very intelligently. And so for us, the next logical step will be, how do we deploy software onto that baseband hotel effectively? SDN will be very crucial, and NFV will be very, very crucial, because that will enable us to deploy access technology, aggregation technology, aggregation application that will enable, that will really blow our minds as we look at the terrain of CRAN going forward. So you can look for us to be very engaged in the SDN and NFV, as well as the 5G technology as we go forward.
Yeah. Well, thank you so much, Femi. It was a pleasure talking to you, as you always.
It's a pleasure. Thank you.
Well, thank you. Thanks for you to listening to this conversation. This conversation was part of a report on CRAN and front haul that Senza Fili has prepared in collaboration with RCR Wireless. Thank you very much for your time. And you can download the report from our website at www.senzafiliconsulting.com and from RCR Wireless website. Thank you.